High revving engines? We've seen it before. Big V8? Nothing new. Turbochargers pushing the limits of combustion? Yep, it's been done. And electric motors enhancing performance? It's practically expected these days. But this combines everything. The Lamborghini Temerario is powered by a 4.0-liter twin-turbo flat plane V8 that screams past 10,000 RPM. All paired with 3 axial flux electric motors, sending a scorching 907 horsepower combined to all 4 wheels. It's a car where if you push one button, suddenly you're driving off the battery alone and powering just the front axle. Yes, you've heard right, an electric front-wheel drive Lamborghini. Yet, push another button and you're in drift mode, happily power sliding thanks to the V8 engine, which is only connected to the rear axle. If it sounds complicated, that's because it is, and you'd rightly be skeptical that it could be pulled off in a refined manner, while still delivering joy through the driving experience. To my delight, it's as fun to drive as it is complex. Clearly, an extraordinary amount of work has gone into the tuning, as you forget about the intricacies of the powertrain once you put your foot down. Yet, it's only through understanding this powertrain that you'll truly understand why it feels the way it does. So let's break it down with far too much detail thanks to a lengthy discussion I had with Lamborghini's Chief Technology Officer, Rouven Mohr. At the heart of it all is the twin-turbo 4.0-liter V8 engine, which makes 800 Italian horsepowers and 730 Nm of torque. For reference, American horses are slightly more powerful, so adjust your numbers accordingly. The V8 has big shoes to fill, as it replaces Lamborghini's glorious 5.2-liter naturally aspirated V10. Of course, the question remains, why ditch the V10? It was actually considered, but ultimately the goal for the car was a significant jump in performance. I'm told anything less than 800 horsepower was off the table. In order to meet those power targets, you'd be looking at a naturally aspirated V10 engine at around 6 liters or more. So think about it. A Temerario with a 6-liter naturally aspirated V10 isn't all that different from the Revuelto with its 6.5-liter naturally aspirated V12. And a boosted V10 would likely exceed the V12's performance. So, in order to have meaningful product differentiation in their lineup, Lamborghini chose to change up the strategy, dropping a high-revving twin-turbo V8 in the baby Lambo, the Temerario. It's fair to be sad about losing the V10, but don't let that discredit this V8 from being something special. In fact, it's a significantly more expensive engine than the V10, and not simply because of the added turbos. Materials selected are one example of the added cost. The cylinder heads are cast out of A357 plus copper, an aluminum alloy Rouven says only a handful of foundries in the world are capable of casting. The same alloy is used in Ducati race bike engines, and to remove weight from the rotating masses, the connecting rods are titanium. The engine layout and design is also more sophisticated. For example, the cylinder head is split into 2 pieces, separating where the camshaft is supported from the portion that handles airflow and coolant channels. And this second piece needs very advanced cooling channels, so intricate that they actually require a 3D printed core for the casting process. Which means, yes, every single cylinder head requires a new, individually 3D printed core for which the alloy is poured into. As you can imagine, this takes a tremendous amount of time, so it's a technique that could not be implemented on a large-scale production engine. Now, typically with direct injection engines, you'd run the high-pressure fuel pump off the camshaft. In this case, the forces on the camshaft would get really high, so in order to keep the camshaft as light as possible, a small intermediate shaft is used which runs the GDI pump. This intermediate shaft, which is ultimately geared to the crankshaft, also helps in significantly reducing the length of the timing chain, which runs off of it. Keeping the timing chain short is critical for ensuring accurate timing at crazy high RPM. In fact, the entire valve train is capable of withstanding 11,000 RPM. Which leads us to the valve actuation. Of course, with an engine that revs to 10K, you need to minimize any possible free play within the valve train. That means ditching any form of hydraulic tappets, replaced instead with direct acting finger followers. This works great for high speeds, But the challenge becomes making it maintenance-free. So this is done by using a special diamond-like carbon coating for the actuators. And then of course, you've got two giant turbos, delivering a peak boost of 1.5 bar over atmospheric pressure. The turbos are so large, in fact, that peak torque from the engine doesn't come on until 4,000 RPM, which makes it sound a lot like an old school turbo solution. But keep in mind, this holds peak torque flat from 4,000 all the way to 7,000 RPM, and power continues to increase all the way till 9,000 RPM, where it finally peaks, but then, surprisingly, remains flat until 9,750 RPM. So, not only is the engine designed to rev high, but you truly should rev it all the way to 10,000 as power continues to climb and simply does not fall off. Rouven told us collectively before heading out to the track, don't shift before 7,000 RPM, as that's where the experience really comes alive. If you think Lamborghini has lost the plot by ditching the V10, I think the most powerful counter-argument comes from Rouven's logic for why the V8 revs to 10,000 RPM. There is no technical reason. A higher boosted, lower revving turbo V8 could just as easily hit these power numbers. This engine revs to 10,000 RPM for the pure and simple fact that it gives it character. In other words, he just wanted it to rev high. Maybe it had something to do with breaking the barrier of the Honda S2000's rev limit in his garage. Clearly a man with great taste. This is something special, and something that is genuinely quite unique in the market of super sports cars, especially at a time when many of the competitors have gone to V6s. But the combustion engine is only part of the story, as the Temerario shares the same electrified portion of the powertrain as the Revuelto. That's 3 compact axial flux motors. 2 on the front axle, which are independently controlled, enabling true torque vectoring, and 1 for the rear axle, sandwiched between the engine and transmission. Each motor individually is capable of putting down 110 kilowatts of power, but keep in mind, this is all coming from a pretty small battery pack, just 3.8 kilowatt hours, yet the battery is capable of a maximum output of 140 kilowatts. So that means at any given moment, you have 140 kilowatts that you can use, splitting that power between the 3 electric motors however you see fit, with no individual motor delivering more than 110 kilowatts. Worth mentioning, these electric motors reach peak power at just 3,500 RPM, which you may notice is before the engine reaches peak torque at 4,000 RPM. So the lack of bottom end as a result of the jumbo turbos is completely filled in with immediate electric torque. And that's really the story of the electrified portion of the powertrain. It's not an overwhelming amount of power, but it's there to mask any perceptible weaknesses of the combustion engine, namely turbo lag and bottom end torque. Combining everything together, and it results in a total of 920 Italian horsepowers and a 0 to 100 km/h time of just 2.7 seconds and a maximum speed of 343 km/h. 900 horsepower is a big number on its own, but it's important to recognize that this is a very beefy 900 horsepower with a very generous area under the curve, which is more important than just peak numbers, as it delivers an abundance of torque whether you're at 4,000 or 9,000 RPM. It's all usable. Which brings us to driving this thing. And I'll be honest, I came into this fully expecting to be disappointed. I realize that's lame to say about a 900 horsepower Lamborghini, but on paper, it is a huge strategic jump on their end that I wasn't convinced was the right direction. The Huracan, again, on paper, sounds much more ideal to me. A big, naturally aspirated V10 in a car that when it debuted weighed nearly 600 pounds less than the Temerario. Less weight, linear power, screamin' V10, what's not to love? But somehow, the engineering team at Lamborghini has made this wildly complex powertrain absolutely deliver. It is stupid fast. Okay, cool, anyone can do that. But it is also stupid fun, and that part is genuinely challenging. The way they've integrated torque vectoring with the electric motors is the most perceptible implementation of this technology I have ever felt, and in a good way. The steering is effortlessly light, but very direct, and turn-in is astonishingly immediate. Bizarre fact, it weighs significantly more than the Huracan, and it has a longer wheelbase, yet it rotates better. What? To better understand this, Rouven provided an explanation on how Lamborghini approaches the car's agility index. Basically, how they use torque vectoring to make the car feel more agile, rotating very quickly, or, on the flip side, more stable, keeping the car planted and sure-footed. Using mostly the electric motors for torque vectoring, in combination with very minimally mechanical brake-based torque vectoring, the agility index of this car is constantly being manipulated, with the two main levers to alter this being the front versus rear torque distribution, as well as the torque vectoring. So, as far as front-rear torque distribution, the more rear biased, the more agile it tends to be, and the more front biased, much like a front-wheel drive car, the more stable it is, as pulling is more stable than pushing. And from a torque vectoring standpoint, you can of course have a torque difference between the left and right tires of the front axle, which creates a torque, helping rotate the car and keep it agile. Or both motors deliver similar torque and the car feels more stable. So with these tools, let's look at how it's implemented into a corner. As you brake, the car remains fairly neutral. Upon lifting off the brake at corner entry, the car quickly becomes very stable, allowing for clean corner entry without upsetting the car. As you begin to roll onto the throttle, the torque vectoring kicks in, helping the car rotate and transitions the car from biasing stability to instead agility. And, completely unlike the Revuelto, which has a different driving characteristic in mind, favoring the front axle for electric power, the Temerario strongly favors the rear axle for electric power, further increasing the agility and giving it a very tail-happy, playful nature. The end result of all of this agility index talk is that you can calculate what is called the virtual rotational inertia of the Huracan or the Temerario, which tells you how quickly the car can rotate. And as the math shows, the Temerario genuinely rotates far faster than its predecessor. And again, that's despite a longer wheelbase and despite significantly more weight. This is all immediately apparent once you get behind the wheel. Turn-in happens so fast, it truly makes the car feel very light and nimble. It isn't necessarily light, but factually, it is quite nimble. And although I have a deep passion for tires and tire technology, I do think modern tires are so good that I believe there's honestly less incentive to make a car ultra-light, because modern tires are so capable of masking the weight. But in this case, not only the tires, but the electrification strategy result in such a delightful cornering experience. Now, speaking of the tires, you can tell Lamborghini isn't dead set on simply achieving the highest single lap performance numbers to appease the major car magazines. These aren't the grippiest tires on the market, but they're extremely consistent. The hot lap pace, before and after 30 laps of tracking a storal circuit, is only off by less than a second. That is to say, the tire maintains the same capability with minimal drop-off as it wears. And to be honest, the car feels more like it'd rather drift every corner than simply go around it quickly, despite both options being possible. In fact, there are 3 distinct drift modes, each level enabling greater amounts of tire slip and sliding angles, that also focuses heavily on ensuring that at the end of the drift, you have a smooth transition back to reality. Indeed, I found the car super playful, even with traction aids on, and even at high speeds, it still encouraged a bit of wheel slip, all while remaining controlled. Combined, there are 13 driving modes, so whether you're dead set on the fastest lap times or would rather go around corners sideways, there's a ton of freedom available in selecting the mode that suits your driving style. Now, speaking of freedom, the Corvette ZR1. Its 5.5-liter twin-turbo V8 making 1,064 horsepower is wildly impressive, especially considering the price that the vehicle comes in at. Yet, I was surprised to find I actually felt like the lower-powered Temerario was quicker. Unfortunately, I don't have instrumented testing to prove this one way or the other, but I do have anecdotal evidence. On the approximately 1.2 kilometer back straight of Circuit of the Americas, I managed to get the Corvette ZR1 up to 175 miles per hour, faster than I've driven on any circuit. Yet, here at the Estoril circuit in Portugal, on the shorter, approximately 1 kilometer main straight, I was able to reach a speedometer indicated 190 miles per hour. 15 miles per hour faster with less space. Now, it is worth mentioning that the main straight of Estoril has a much better corner entry speed, whereas Coda is a hairpin. but the added nearly 0.2 kilometers in length at COTA should help make up for that difference. It's also worth mentioning air temperatures were much hotter when driving the Corvette. Though, admittedly, one of the advantages of an electrified powertrain like the Temerario has is that it's less impacted by higher air temperatures, as electric motors don't care. They'll make their power all the same. 190 miles per hour in less than a kilometer is truly something. This thing rips, and it never lets up. Speaking of straight line speed, launch control. A simple button push, then mash both pedals, and suddenly two really cool things happen. Of course, the revs build up for the launch, but the electric motor, stuck on the end of the engine, actually goes into regen mode, providing a braking torque to the engine, allowing it to build boost for an epic launch. How clever! And second, the red line is actually increased to 10,250 RPM. Lamborghini admits this is an unnecessary RPM hike, but it's done purely so that the driver can ensure they cross over and experience the thrill of 10,000 RPM. We'll get into the vehicle's drawbacks in just a second, but as far as all of the driver inputs, they're fantastic, and I imagine this is quite a challenge on such a complicated vehicle. The throttle control was very linear, every engineer's dream, and turbo lag, which is very real with giant turbos, at least on track, was genuinely imperceptible. The electric motors do an excellent job of delivering torque when the V8 cannot, and seamlessly fade away as the boost builds. To all but the most perceptive, this absolutely drives as if it were naturally aspirated, with very precise throttle control based on pedal position. The brakes too are excellent. It's brake-by-wire, which many enthusiasts resent. But again, you'd never know unless you were told, and it has excellent pedal feel, with low travel and pressure-sensitive braking, blending the mechanical brakes with the electric motors, which are capable of sending 100 kilowatts of regen power to the battery. As far as the gear shifts, wow, the shifts. Each shift from the 8-speed dual-clutch transmission is an event, and this is intentional. You lose forward momentum for a brief moment, lurching your body forward, and are then slammed back into your seat as power resumes. I'm told part of this effect is actually done by using the front motors for a brief moment of regen during the shift. Different driving modes change the overall shift behavior. And as mentioned, the steering is light and very quick, giving the impression the car is lighter than it is. But this does lead me to one of my few complaints. This very light, very nimble steering feel remains this way under heavy braking at the end of a long straight. As a result, the car feels a bit darty under heavy braking, wobbling about if you're not rock steady on center with the steering wheel. I discussed this with Rouven, and he said it is an intentional choice, which is apparent when looking at the agility index I discussed earlier. Under heavy braking, Lamborghini is intentionally choosing to make the car more neutral, rather than more stable. Rouven said this is purely a personal preference thing, and they do it because it gives the driver more information, as far as any bumps on the road, and allows you to properly feel what is happening to the car. Personally, I found that it occasionally meant I had to correct, and then continue to correct, any side-to-side wobbling that I may have caused by giving it a slight steering input. My second complaint is simply the noise levels of EV mode. As mentioned, and somewhat hilariously, this car offers a front-wheel drive, electric-only driving mode. It's only good for about 6 to 10 kilometers, of course depending on how you drive, but actually it did feel like a pretty normal EV driving experience. The downside is that the pedestrian warning sound is fairly noisy below 40 kilometers per hour, and above 80 kilometers per hour, the motor noise gets pretty loud. So overall, it's far from a quiet EV driving experience. But let's be honest, this isn't an EV, and with the engine on, I never even noticed the front motor whine. And finally, there's the obvious downside of the vehicle's weight, though they have done a great job of masking it. But worry not, for $49,113, the cost in the US market, there is a lightweight package. It reduces the car's 1,690 kilogram dry weight by 12.65 kilograms. That's almost $2,000 per pound removed. Now, the package does also significantly increase downforce, and paired with the $26,200 carbon rims, as well as some other interior bits, you can get the weight savings over 25 kilograms. But yeah, it might just be worth skipping lunch on your track days, saving a little bit of weight, and pocketing that extra cash. So a few minor complaints, which is honestly impressive, especially considering the complexity involved here. It really is a joy to drive. It really is insanely fast, and it really does offer a unique experience in a world where everyone is chasing performance, but far fewer truly focus on delivering smiles. Hats off, Lambo, this one's fun. If you're sitting at home and you've got $382,654 that you just can't quite figure out what to do with, I'm happy to send you my Venmo details. If you have any questions or comments, feel free to leave them below. Thanks for watching.